It is. It's 1 minus 1/2 times 0. So it is 0. Yeah. Okay, great. So the other thing that we started talking about were the reciprocal functions. And for example, like the cotangent of, let's go pi over 6. So to do this, you first need to figure out what is tangent of pi over 6, because cotangent is the reciprocal of tangent. So you either find tangent and flip it, or a few options here. So tangent pi over 6 is sine pi over 6 over cosine pi over 6, which is 1/2 over the square root of 3 over 2. And whenever you have the same denominators, they just cancel. So it's 1 over the square root of 3. Okay, so that's tangent. Now we could rationalize this, but because we want to flip it, you don't always want to rationalize. So to get back to here, you would actually just realize, oh, it's 1 over the square root of 3, which when you flip it, the bottom goes away, so it becomes square root of 3 over 1, or just the square root of 3. So sometimes, sometimes it works out nicely. Sometimes you don't want to simplify all the way through, but it's okay if you can, if you need to. Let's look at another one here. Again, this is all review, but it's good review. It's important to just keep firing away at this stuff. So like secant of let's go pi over 4. Okay, so this is 1 over the cosine of pi over 4, and the cosine of pi over 4 is the x value. So we would write it as 1 over the square root of 2 over 2, which becomes, you got to flip the bottom here. Whenever you have 1 over something on the bottom, you flip it, so it becomes 2 over root 2. And then you can rationalize, and rationalizing, you multiply the top and the bottom by root 2. So 2 root 2 over 2, the 2's cancel, and you just get square root of 2 when you do that. And there are 3 reciprocal functions that we have to look at. The last one is cosecant. So we'll do cosecant of pi over 3. So cosecant of pi over 3 is 1 over the sine of pi over 3. The sine of pi over 3 is root 3 over 2. So it's 1 over root 3 over 2. And so you flip that, it becomes 2 over root 3. And then you can rationalize by multiplying the top and bottom by root 3. So it's 2 root 3 over 3. No cancellations, but you can see that that works there. So what you have to be comfortable with is I could give you the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent of any angle in the first quadrant, and you should be comfortable finding that. And for now, we're just going to look them up. We're just going to use the unit circle, but like on the test, obviously you wouldn't have this, but you'll get faster as the more time goes on. And this is used in calculus, so you'll see it again. All right, so let's try sine squared pi over 4 plus cosine squared pi over 4. And I mentioned this last time, when you see the 2 here, what that really is you find the sine of pi over 4 and then you square it. Same thing here, the cosine of pi over 4 and then you square it. So will you go ahead and try to find the value of that for me, please? How are you doing on this?
I got 2 as my final answer.
So sine of pi over 4 is square root of 2 over 2, and then we square it. When you square it, you square both the top and the bottoms. The square on the top undoes the square root. On the bottom, it makes 4. And then cosine pi over 4 is also square root of 2 over 2. Squaring it, you get 2 over 4. So because the denominators are the same, you can just add the numerators. It becomes 4 over 4, which equals 1.
Okay.
Okay. Okay, let's try another one here. Let's go 1 minus cosine squared 30 degrees and over 1 plus sine 30 degrees. And let me actually just move this down so you can see that part of the first quadrant. Hey, so I stepped away for a moment. Do you have any questions on this one?
Not so far, I don't think.
Okay, all right, keep working on that. All right, do you have an answer on this one?
1/6.
Okay, so did you get square root of 3 over 2 squared for cosine 30?
Yes.
Okay, and then sine 30 is 1/2.
Mhm.
So on the bottom, it is 3/2. Hopefully you got that. And then 1 minus, so when you square the square root of 3, that becomes 3, and the 2 goes to 4. So 1 minus 3/4, you can think of 1 as 4 over 4. So
Mhm.
that gives you 1/4 over 3/2. And then you multiply by the reciprocal, top and bottom. So we haven't done that in a while, but it's 1/4 times 2/3. The 2's cancel, and you get 1/6, like you said. Perfect. Okay.
Okay.
Fantastic. All right. So so the next thing I want to talk about briefly here, because we really can't do any other problems until you learn how to determine uh, the the sine, cosine, tangent, et cetera, of other in other quadrants. So let me just show you the whole unit circle, and we'll just agree that this is a lot to remember. You definitely don't want to do that, but I'm going to show you a shortcut here. And the first shortcut here is that we need to know how to find what's called the reference angle.
Mhm.
Okay, and the reference angle is the angle made with the x-axis. Okay, and there's tons of videos on these online, so I'll just briefly cover this, and then we can move on to another topic, or we can spend more time, up to you. But let's say I wanted you to find the cosine of 150 degrees. Okay, and if we look at the unit circle, here's where 150 degrees is. That's not drawn very well. Here's 150 degrees. It's right there. But what is the angle made with the x-axis? What is this angle here? Well, if this is 150, that's 180 to get all the way. This angle must be 30.
Mhm.
So the cosine of 150 degrees is equal to the cosine of 30, because that's the reference angle, but you have to figure out whether it's plus or minus. Okay, and that's a bit more work. So we're going to focus on two things, figuring this out. So there's this convention called Astc, and here's what it means. It means that all of your trig functions are positive in the first quadrant. You see how all the outputs are positive in the first quadrant? That's
Yeah.
what the A stands for. The S stands for sine. It says that sine, or the y values here, oops, I'm so sorry. Let me see if I can correct that. There we go. The y values in the second quadrant, the y values are positive. So see how they're positive here?
Yeah.
So the letter S in this case means that sines are positive, the y values are positive, but it also means that everything else is negative. So the cosine is negative in that quadrant. So the cosine of 150 is equal to the negative of the cosine of 30. So the cosine of 30, you're going to know, is square root of 3 over 2, but because you're in the second quadrant over here, it's negative. So what we're gonna work on is building the reference angle, and then knowing whether it's positive or negative. Okay. So I'm gonna grab this unit circle again. We're gonna do a lot of these types of problems here. So let's say the angle. Let's say I want the sine of 225 degrees. So there's 225. There's 225. And this is the reference angle. So it's always the angle made with the x-axis. It doesn't matter whether you go past it or up here. It's the angle with the x-axis. So what is the angle with the x-axis? What is this angle here? Can you tell me?
Wait.
This
So
angle right here.
all of that is
So it's, if you go all the way around, like if you get to here, that's 90, then 180, then 225. That's 225 when you go all the way around. But I don't want that. I just want the part from here back to that. And you can see I've drawn a triangle here.
Mhm.
You can also kind of see what it points at over here. That is important. Points at 45 degrees. This is a 45-degree angle. So
okay.
what some students do is they try to learn rules like it's 225 minus 180. That only works sometimes though. So that's not great. You sort of have to like intuitively go, okay, well, it's this angle right here. It's somewhere between 0 and 90. So the reference angle is always between 0 and 90. So it's always
Okay.
between 0 and 90. You would never tell me it's 200. It's always 0 to 90. Okay. So that means it's either plus or minus sine of 45. Now ASTC. So in this quadrant, tangent is positive. That means sine and cosine are negative. So that means it's negative in this quadrant over quadrant 3. So the sine of 225 degrees is equal to the negative sine of 45 degrees. And so if you know your first quadrant really well, you know the sine of 45 is root 2 over 2, and then you just negate it. Okay, so we're going to go to the fourth quadrant now and do an example. Okay, so let's say I want the cosine of 300 degrees. Okay, so where's 300 degrees? It's right there, and you go counterclockwise. So if you go that way, it's 300 degrees. But what you want, and I guess I should have done this before, you need this angle right here. What is this angle in red? You can get that by visualizing a triangle here. And maybe you can see that that is 60 degrees, that angle right there. It's 60 degrees because to go all the way around is 360. You've gone 300, so to go back is 360.
Okay.
Okay, so this is equal to, the cosine of 300 is equal to plus or minus the cosine of 60 degrees. So we have to figure out, so ASTC. So in the fourth quadrant, which is where we are, cosine is positive. So we choose the positives. This is just cosine of 60. There is a way to do this without learning the entire unit circle, which is what we want here. Okay, so what I'm going to do is give you a few examples here. We're going to stick with degrees. So the question here would be something like the cosine of 135 degrees is equal to the, and this is what you're going to tell me. It's plus or minus cosine and then the angle that goes in here. So I'm looking for two things from you, this and this, the angle, and then whether it's positive or negative. All right, how are you doing on this one?
Is the angle 225?
The angle has to be between 0 and 90.
Oh, okay.
This angle is always between 0 to 90. And it's right here. It's this one right there. Because it's always with the x-axis. Like you figure out where you are. That's 135. And then you draw this triangle. You're just trying to figure out this base angle down here. So like if you were in blue, I mean, there's a couple ways to this, but if you're in blue to go all the way, this is 180. But we're not going all the way. We're going 135. So how much is remaining? It's like, the total trip is 180 miles, but you've gone 135. How much is remaining? 45.
45.
Yeah. And then it's ASTC. So is cosine positive or negative in the quadrant? Remember, the letter tells you which one is positive. All positive, sine is positive, tangent's positive, cosine's positive in that quadrant. So is cosine positive or negative in that quadrant?
Cosine is negative.
It's negative because sine is positive, so everything else is negative. Okay, good. All right, let's try another one here. All right, let's do the tangent of 120 degrees. So again, what I'm looking for is whether it's positive or negative, and then the tangent, and you've got to figure out the angle measure, and there's 120 right there. So I'm looking for this angle down here in red. It's always the angle that's made with the x-axis. That's this part right here.
Okay. To figure out tan, is it the same way that we've been doing with the?
It's a little, I mean, it's somewhat related, ASTC. So so I was just trying to see where you're at on this. How about the angle? Do you have that first? Then we can talk about the plus or the minus. What is the angle that goes here?
60 degrees.
6 degrees, perfect. Okay. Now, sine is positive, but cosine is negative in that quadrant. And tangent of an angle is sine of an angle over the cosine of that angle. So if sine is positive and cosine is negative, what is tangent in that quadrant? What is a positive over a negative?
A negative.
Negative, yeah. So that is the mental gyrations to go through that. Yeah, let's do another one here. So let's do the cotangent of 210 degrees. So again, it's cotangent plus or minus, but we got to figure out the angle there. And there's 210 degrees. And we want this angle right here. Obviously, it helps to have that unit circle there, but sorry, do you have the angle here?
30 degrees.
30 degrees, okay. And then to think about cotangent, we know ASTC. So tangent is positive. Tangent is positive.
Mm-hmm.
And we know that cotangents are reciprocal of that. So the way to think about that is tangent, let's just say the tangent angle sine theta over cosine theta. If they're both positive, well, when you flip it, that is also positive over a positive. So it's still positive. Does that make sense?
Yeah.
All right. So let's do one more and then we'll move to, we'll do a little bit more review on some lines. All right, so let's do the secant of 315 degrees. So again, that's plus or minus secant, and then figuring out the angle. There's 315 degrees. You can draw the triangle if it will help. The reference angle is always the angle made with the x-axis. So give that a try, please. All right, how are you coming along with this?
Okay, so I got 45 degrees.
Okay,
And then I said it was minus.
so cosine is positive in the fourth quadrant, and secant is 1 over cosine. So if you have 1 over a positive number, that is a positive.
Oh, positive. Okay.
And so the mistake is really to, I'm not big into memorization. I think we've talked about that before, but I mean, you could do it here. I like to kind of work through it. Like, okay, cosine's positive, so 1 over a positive is a positive. Okay, so let's go talk about something totally different here. Let's talk about parallel lines. So if I tell you that y equals our lines in general, y equals 3x plus 1, and then I tell you that y equals kx plus 5, and we want these two lines to be parallel for the moment. Parallel lines have what? Same slope. So what would k be for these to be parallel?
Um,
What's the slope of line 1? Start there.
oh, 3.
3, and then the slope of line 2 would also have to be 3. Okay. For perpendicular, the lines, the slopes are opposite and then reciprocal. Okay. So and what's awkward about this is you're not used to there being a letter here, but another way of looking at this is that the product of the slopes, this is actually the correct way to do it. The product of the slopes is -1. Okay, so in other words, we take 3 times k, and that has to equal -1. We'll divide by 3. So k is -1/3. Okay, so now that we have k, let's go back and look at that. If k is -1/3, is that the opposite reciprocal? Well, yeah, it goes from positive to negative, and then the reciprocal of 3/1 is 1/3.
Okay.
So the reason I want you to do it as the product of the slopes is -1 rather than the opposite reciprocal is because I'm going to give you more complex problems than just where you can read it off. So let's say the slope of the first equation is -3/4 x minus 2, and the second equation is kx plus 1. Okay, if we want these slopes to be perpendicular now, we're no longer going to do parallel because parallel would be the same. The product of the slopes has to equal -1. So you have to be able to solve this type of equation. Okay. And I can obviously change this too. I could make this like 1 over k. I could make it a lot more complicated, but for now we'll just deal with k as the fraction there. So to do this, you either have to rewrite this as a fraction or you have to clear it. So -4/3, -4/3. So k is equal to 4 divided by 3.
Okay.
So for perpendicular slopes, the product of the slopes has to be -1. Okay, so let me give you a problem to try. Let's say y equals 5/4 x minus 3, y equals k x plus 2. Can you find the value of k so the slopes are perpendicular?
Wait, which equation do you use?
Well, you need both equations. You have to set you need the slope of the first equation. What's the slope of the first equation? 5/4.
Mm-hmm.
The slope of the second equation is k, and the product is -1.
Okay.
So you're just solving for k in this case.
Oh, okay. -4/5.
-4/5, yeah. Okay. So just to make the problem just slightly more difficult now, what we can do is say, okay, let's say that it's -2/3 x minus 5, y equals 2 over k x plus 3. And again, I want you to solve for k. I want you to find the value of k that makes these two lines perpendicular. So the lines are perpendicular when the slopes, the m's, the product is -1. So you have to take the -2/3 times the 2 over k, and that equals -1.
Okay.
There's a bit more involved in this one. This time you do actually want to multiply the numerators and get -4 over 3k equals -1 over 1. And then you want to cross multiply. So you want to butterfly, or you're going to multiply those together, and divide by -3. Would you like to try one more, or do you want to end the lesson here?
Can we try one more?
Yes. Okay, so let's say y equals 5/4 x minus 1. And the next one is, oh, let's go 6 over k x plus 5. Same thing here. You want to take the slopes, multiply them together, and the product has to be -1 here. So go ahead and give that a try and see what you come up with.
So you multiply slopes together, so they add up
Yes,
-1?
the product is -1
Oh,
for them to be
okay.
perpendicular. And that's the same as opposite reciprocal, but you can't use opposite reciprocal in this context. It's a little awkward. We can show you, I can show you another approach, but we'll just keep working on these, because this is a good practice for solving, you know, these awkward fraction problems that inevitably show up on standardized tests. So when you cross multiply, hopefully get 30 equals -4k, and then you divide by -4. Don't forget to reduce. K is -15 over 2.
Okay.
All right, well, let's take us to the end of our lesson today. We'll start back here in about 10 minutes and I'll see you shortly. Thank you so much.
Thank you.
Okay, bye.